lecture 9 in signals and systems. In previous lecture 8, we have discussed some properties of impulse function, and I introduced the discrete time signals, that is impulse sequence or impulse function, unit step sequence and a ramp sequence, right? And in this lecture we will continue with the discrete time signals, and we will also do some operation on discrete time signals. Now before continuing this, so I introduce one more property of impulse function of continuous impulse function. One more property, that is I think the seventh one, right? The last one. If the power delta dash of at plus b is there, right? So it can be represented by 1 by a into mod a, right? Del dash of t plus b by a. So this is one more property of a continuous impulse function, continuous time impulse function, right? Next we will see some properties of discrete time impulse function. Only one or two will be there. That is, first one, suppose if x of n is multiplied with delta n, so what is the value? We will get x of 0. Similarly, x of n delta n minus n naught, so what is the value? We should get x of n naught. These are the two properties in discrete time impulse function. Next we have to know what is the relationship between delta n and u of n, the impulse sequence and the unit step sequence. Here we know that u of n is equal to from 0 to 1 to etc n, this is the 1, right? Similarly, what is the impulse function? This is the 1. Suppose if I want delta n, suppose if there is one u of n, if I right shift one time, that is u of n minus 1, and subtract, so we will get delta n. Delta n is equal to u of n minus u of n minus 1. This is the delaying, or we can say the property of this impulse function, or relation between unit step and impulse function. Similarly, if I want u of n, then you can summate m is equal to 0 to infinity delta n minus m. Now this is the unit step and del function relationship. Suppose m is equal to 0, we will get delta n. M is equal to 1, delta n minus 1. M is equal to 2, delta n minus 2. So it's nothing but unit step function. If I want this one, u of n, and one term is right shift, that is it will start from 1. So if I subtract from 1 to infinity, it will be cancelled. Only will get as impulse function. So these two are the relationship between impulse and unit step sequences, right? Next we will see complex exponential sequence or signal. So it is in the form of c into alpha per n, and c and alpha are now in complex numbers. So complex numbers can be represented by magnitude and phase. So x of n will become like this. So mod c e power j theta into mod alpha into e power j omega naught power n. So it will become like this: mod c mod alpha and e power j omega naught n plus theta. So this is in the complex exponential. So this can be represented by like this also: mod by Euler's relation mod alpha. So it will become cos n omega naught plus theta plus j sin n omega naught plus theta. This is x of n. Now, so this is a magnitude and this is the sinusoidal signal, so it's a cos form and it is sine form. So what is the representations here? We will get here 2 again, right? This if alpha is less than 1, see, between 0 less than alpha less than 1, one sequence we will get. If alpha is greater than 1, we will get one more sequence. If alpha is less than 1, it will be exponentially decaying function, we have seen already. So this is the one. So exponentially decaying means it will come from somewhere else, and when alpha is greater than 1, it will be the raising function, right, somewhat like this. Now but it is a sinusoidally, so it will be like this. So and it will decrease like this, then again it will be like this, and so on. Again it will decrease, and so on. So something like this will get the sequence, right? It will go on decreasing. Similarly, if it is an increasing function, so something like this we will get with respect to sinusoidals only. So it will be increasing. So this is the exponentially increasing sinusoidal sequence, etc. So this is for alpha is less than 1, this is alpha is greater than 1. Now the C is simple one, that is the sinusoidal sequence, that is like this. Sinusoidal sequence, right? So x of n is equal to in the form of a into cos n omega naught plus theta, right? It's very simple drawing. This is x of n, so it's a cos function, so I will draw dot lines first, then we will make a sequence, right? So impulse, then it will reduce, right, up to 0, then it will again increasing, something like this we will get, and so on. Similarly here also reducing 0, then the sequence will be there like this. So you can have different sequences, and so on. So this is the sinusoidal sequence, right? The last one is now what are the periodicity properties? So periodicity properties of complex exponential sequence. Complex exponential sequence. So if I take x of, this is the important one, x of n is equal to e power j omega naught n. So this sinusoidal sequence, this complex exponential sequence are generally periodic in nature, right? So it is a periodic in nature. Now how to find that periodicity or a period is, suppose we know the property x of n plus n, if it is equal to x of n, then we can say x of n is a periodic sequence. Now this is we have to prove now. So that means x of n plus n is equal to e power j omega naught n plus n, so which will become e power j omega naught n into e power j omega naught capital N. Now if x of n plus 1 is equal to e power j omega naught n, what should be this term? It should be 1. That will take next page. So that means e power j omega naught capital N will become 1. Then only x of n is equal to x of n plus 1. That is e power j omega naught n is equal to e power j omega naught n into e power j omega naught capital N. If this term is 1, then only x of n is equal to x of n plus 1, n plus n. This is 1. Now to make 1, how to make e power j omega naught n? If I replace with e power j 2 pi some m, a integer. Now e power j theta, so it can be replaced by cos theta, cos 2 pi m plus j sin 2 pi m. Now for any value of m, this will become 0. but here m is equal to 1, n is equal to 2, etc. So it should be in integer form. So can I replace omega naught n is equal to 2 pi m? Right? So that means omega naught by 2 pi should be equal to m by n. So this omega naught by 2 pi should be a rational number. Then only we can say the given signal is periodic, right? Or this can also written like this: n is equal to 2 pi by omega naught into m. Now n is the periodicity or periodicity of the period signal or x of n, right? So this is the smallest integer to make 2 pi by omega naught is rational, right? So we need to take the smallest integer to make this 2 pi by omega naught as rational number, right? So when we do problem, that will be clear, right? So this 2 pi m, so whenever cos 2 pi is there, it will become 1, then cos 4 pi, then cos 6 pi, etc., right? So then only if this function will become 1, so we can say x of n is a periodic in nature, right? So this is about the periodicity of a complex exponential. Now if I take example how to say, suppose some question is given like this: x of n is equal to e power j 2 pi by 3 into n. How can we say that is a periodic, and what is the periodicity? Now you have to compare with the e power j omega naught n always. So what is omega naught? Is nothing but 2 pi by 3, right? So by periodicity property, omega naught by 2 pi should be equal to m by capital N. Now, or we can say n is equal to 2 pi by omega naught into m. So 2 pi by omega naught is given as 2 pi by 3 into m. So 2 pi cancel, it will be 3m. Now what is the smallest integer to make this one is rational number? So nothing but m is equal to 1 only. So n is equal to 3. So this is the periodicity, period, right? And remember, then the period should be integer number. It should not be 3.5. It should be 3, 4, 5, etc. Right? If I take same example, x of n is equal to e power j 2 by 3 of n. I am not considering pi here. So what is omega naught here? 2 by 3. Next, n is equal to omega naught by 2 pi into m. What is omega naught? 2 by 3 into 2 pi into m. So 2 cancel, 1 by 3 pi into m. Now we cannot make, say, anyway, the moment pi comes, it's a irrational number. Even if you put any integer, it will become irrational. So that is n by m is irrational number. That is x of n is a periodic sequence or non-periodic signal, right? It's not a periodic signal. So the moment you can compare now, so there is a blind rule. If the exponential sequence is containing a pi, so it is a periodic, right? The moment there is no pi in the sequence, that means it is not a periodic signal. That is the blind rule. You can remember for gate purpose. If it is containing pi, it is a periodic. If it is not containing pi, it is not a periodic, right? Now what happens when two signals are there? Suppose x of n is equal to e power j 2 pi by 3 of n plus e power j 4 pi by 3 of n. These are two sequences are in addition. Now, so separately we will find the periods, then we can have the LCM of those periodics. Now suppose what is n1? 2 pi by omega naught. Omega naught is 2 pi into 3 into m plus, so not plus, n2 is equal to 2 pi by 4 pi by 3 into m. So what is this? pi cancel, this is 2, this is 3 by 2 m, this is n2, n1 is simply 3m. Now in this case, what is the smallest integer to become n1 is integer 3. Here n2 is equal to what is the smallest integer to make this n2 as integer, so we need to substitute m is equal to 2, so 2 cancel, it will become 3, right? See, n2 by m is integer because 3 by 2 is 1.5, so it is a rational number, so then it is a periodic signal. Now what is the smallest integer to make this n2 as integer is again m is equal to 2. Now if you see these n1 and n2 both are same, right? So what is the LCM of n1 comma n2 is nothing but 3, so the period of the summation of these two signals is nothing but 3 only, right? That is the sum. Now similarly, if you are having 3 signals, that is x of n is equal to e power j 2 pi n plus e power j 2 pi by 3 n plus e power j 5 pi by 3 n, then what is the fundamental periodic? Now same, n1 is equal to 2 pi by omega naught, so 2 pi by 2 pi into m, so this is m, say smallest integer is nothing but 1 only. Next n2, similarly 2 pi by 2 pi by 3, that means 3m, so 2 pi cancel, you will get 3, the smallest integer is m is equal to 1. Similarly n3 is equal to 2 pi by 5 pi by 3, so it will become 3m, so pi cancel, it is 6 by 5 m, this is n3. Again n3 by m is a 6 by 5 is a rational number, so what is the smallest integer to make n3 as integer? It's a 5, so n3 is 6. Now what is the LCM of 1 comma 3 comma 6? So that is the sequence of n or time period of the total signal. So what is the LCM? We will get 6. So 6 is the periodicity of the x of n. So this is how to proceed. Is it a periodic or non-periodic? Is it a how to find the period of the given signal? Now remember, the moment there is no pi in any of the sequence, so it will become non-periodic. Even if this is periodic, this is periodic. If this is non-periodic, so the whole signal will become non-periodic, right? So this is about some discrete time signals and this one, how to find the period. Next we will see operation on this discrete time signals. Operations on discrete time signals. Simple same operations. One is time shifting, next time scaling, then time reversal, right? Now what is the time shifting? So it will be either left shift or right shift. So time shifting is, so one is left shift, that is x of n is there, then x of n minus n naught, it's a right shift, or we can say delaying, so right shift. Next x of n is there, then x of n plus n naught, so it is a left shift, right? Or it is a advanced version, or this one is a delayed version. So this is a delayed, that is it will come after some time. Advancement, it is coming before the either some time, right? So that's why it is advanced, this is delayed version, right? Next we will see the time scaling in discrete time sequences. So the notation is like this: x of n is a, then scaling means x of an, right? So depending on the a, we will get expanded or compressed, right? So that is like this: if a is less than 1 and if a is greater than 1, so here we will get expanded version of x of n. Here we will get compressed version of x of n. Now how we'll see one example. Suppose some sequence is like this. So at 0 there is a 2, at 1 1, at 2 there is a 4. Similarly same minus 1, and this is 4, this is a minus 2. So this is x of n. Suppose if I want x of 2n, that is a is greater than 1, that means we know that each will be multiplied with 2, I mean divided by 2, 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 divided by 2. Now the moment we are getting some the decimal point, that is minus 0.5, this is 0.5, so it will be directly neglected. Only it will take integers. So integers is at 0 we will get 2, and at 2 by 2 that is 1, so you will get at 1 only 4. Similarly minus 1 as 4. Now see, this is a compressed version compared to this one. So that's why when a is greater than 1, x of 2n will get compression. Next one is, suppose x of n by 2 is there, right? That means each will be multiplied with 2. So what we will get at 0, if this is 1, so it is multiplied with 2, so we will get at 2. This is 2 and this is 1, and 1 is missing, so 1 is 0 we will get, but 2 we are getting 1. Similarly there is a 2 into 2 we will get 4, right? So at 4 we will get as amplitude as 4, right? That means 2, 3, 4, so 3 is missing, this is n. Similarly here also minus 1 will be missing, and we will get minus 2, and minus 3 will be missing, we will get minus 4. So minus 2, sorry, this will be 1, and minus 4 will get us 4. Now here we are adding zeros, so generally this expanded version sometimes we will call it as interpolation, right? So we are adding zeros when we are expanding, or when a is less than 1, so this total sequence is expanding himself. Here it is compressing itself. So interpolation means we need to add zeros at the some integer values. So this is the time scaling concept. Next we will see the last one, time reversal. It's very simple. So time reversal, so it is like a folding the sequence. Suppose x of n is there, or the time reversal it is x of minus n. That means the positive side sequences will come to the negative side, negative side sequences will come to the positive side. That is, suppose this is u of n, 0, 1, 2 and so on. Suppose this is n and this is u of n. What is the u of minus n? Is nothing but this positive sequence, it will be folding like this. So from 0, 1, and it will become minus 1, minus 2 and so on. This sequence, anyway, the reversal we know the process, right? So this is some operations on the these sequences, and we will have amplitude scaling also, amplitude scaling, amplitude additions. That is very simple, so that we will see in the problems, right? So those problems we have to solve, so that is we will see in the next lecture, right? Now we will see the discrete time complex exponential sequences or signals. Now it is in the form of x of n is equal to c into alpha power n, where c and r are complex numbers, right? Now depending on the c and alpha we will have different, that is, part A is real exponential sequences, real exponential sequence or signals, right? Now if c comma alpha are real numbers, then we will have real exponential sequence. That means x of n is equal to c into alpha for n. Now suppose if c is equal to 1, and if c is equal to 1 x of n will become alpha power n. If it is a constant, it can be anything. Alpha can be replaced by some a, this is b, etc. So any arbitraries you can take. It's not about if c is equal to 1, x of n is equal to alpha over. Now depending on alpha value, we will have different types of sequences. Suppose if alpha is between 0 less than 1, if between this is the 1, what is the sequence we will get? So that means I have to take alpha as suppose 0.5. Now if it is a 0.5, it is like this. So x of n is equal to 0.5 power n. Now what is the sequence we will get? This is the n and this is x of n. If n is equal to 0, so 0.5 or 0 we will get as 1. If n is equal to 1, so 0.4 power n we will get 0.5. It is next 0.5 power square, so it will be decreasing function, right? Exponential decaying function is when alpha is less than 1 and between 0. Suppose if alpha is greater than 1, we will get one more different sequence, that is n. If alpha equal to 0, n is equal to 0, 0 power 0.5 power 0 or alpha power 0 is 1 only. So again we will get 1. Now that is greater than 1 means suppose 2. So what is x of n? 2 power n. That is 2 power 0 1, 2 power 1 2, 2 cube or 2 square 4, 2 cube 8 and so on. So this is exponentially raising sequence, right? So it is raising function always. So whenever alpha is greater than 1, we will get one sequence. Whenever is alpha is less than 1, we will get different sequence, right? Now you can have, suppose alpha is less than -1 or alpha is between 0 and -1, then we will get different sequences. So I'm not going to do that. So if depending on the alpha, we will get different sequences. Next one we will see this complex exponential. This is B, complex exponential sequence, right? So that means x of n is equal to c into alpha power n, and c is complex number, so that complex number I am taking as mod magnitude and the phase. Similarly alpha is also, right, so it should be complex number, so some e power j omega naught is a complex number, or e power r plus j omega naught, right?